So L'Hopital's rule states that if f of a and g of a are both equal to 0, and the derivative of f at a and derivative at g of a exist, and the derivative at g of a does not equal 0, then when you're doing the limit as x approaches a of f of x over g of x, that's the same as saying the limit as x approaches a of f prime of x over g prime of x. So substituting in a f prime of a over g prime of a. So what this means is that the limit as x approaches a of f of x over g of x is equal to f of a over g of a, which makes 0 over 0, then you can take the limit as x approaches a of the derivative of f over the derivative of g, substituting in a. The first example, we have the limit as x approaches 3 of x squared minus 9 over x minus 3. Substituting in 3, the numerator is 0 and the denominator is 0. So then L'Hopital's rule will be able to apply. So by L'Hopital, we can take the limit as x approaches 3, deriving x squared minus 9 to make 2x, and deriving x minus 3 to make 1, then substituting in the value of 3, and the answer for the limit is 6. In the next example, the limit as x approaches 2 of the square root of x plus 2 minus 2 over x minus 2, substituting in the value of 2, it's 0 in the numerator and 0 in the denominator, so L'Hopital's rule will apply. So by L'Hopital's rule, we can take the limit as x approaches 2, taking the derivative of the numerator, which is 1/2 x plus 2 to the negative 1/2, derivative of the denominator, which is 1, then substituting in the value of 2, so we have 1/2 4 to the negative 1/2, which then makes 1/4. Next example, we're going to look at the limit as x approaches infinity of x minus 3 over x squared minus 9. Substituting in infinity, we wind up with infinity over infinity. L'Hopital's rule also applies to infinity over infinity. So taking the derivative of x minus 3 is 1, and derivative of x squared minus 9 is 2x. We get 1 over infinity, we substitute infinity, and the answer is 0. The next example, we're looking at the limit as x approaches infinity of x squared minus 9 over x minus 3. Again, getting infinity over infinity. So by L'Hopital, the limit as x approaches infinity of 2x over 1, then substituting in the value of infinity, we get infinity as a limit.